This is the homework for 8, 136, 138, 139, 141, and 142. In problem 136, you need to rewrite each expression in simpler form. So we have 3 to the second multiplied by 3 to the fifth. So that would be 3 times 3 multiplied by 3 times 3 5 times. So we have 2 3's and 5 3's. So altogether we have 7 3's. So it would be 3 to the 7th. So the rule is when you're multiplying integer exponents with the same base, you're going to add the exponents. 2 plus 5, which is 7. For problem B, you're dividing integer exponents. And the first thing you want to ask yourself, do you have more 4's in the numerator or the denominator? And here we have 5 4's, and in the denominator you have 3 4's. So we know we're going to have more 4's in the numerator. So the rule is, if it's a fraction, think of subtraction. So I'm going to subtract, and I'm going to use the fraction bar to remind myself that I'm subtracting. You keep the base, and you can only do this when you have like bases. So it's 4 to the fifth, minus a positive 3. 5 minus 3 is 2, and 4 squared is 4 multiplied by 4, which equals 16. In problem C, we have to distribute this exponent, the 4. So when you have a power raised to a power, you multiply. And when you're multiplying, if it's in parentheses, this exponent is distributed to both terms. The 3 is a term, so we have 3 to the first, and then x squared is a term. So there's 2 terms, and that's why you're distributing it to both of these. And I put a 1 here because anything to the first power is itself. So I have 3 to the first power multiplied by 4, which equals 3 to the fourth. X to the second power multiplied by 4, so that's 2 times 4, which equals 8. Now if the exponent is 4 or less, I want you to simplify it. So this is 3 times 3 times 3 times 3, which equals 81. So 81x to the 8th. In D, we're multiplying these two terms. And so we have 3 and 7 are like terms. And remember, commutative property, it doesn't matter which order you put them in, because 5 multiplied by 2 is 10, and 2 multiplied by 5 is 10. So you can switch them around. It doesn't matter the order. So I have 3 and 7, and these are like terms. So 3 multiplied by 7 is 21. And then I have x to the third multiplied by x to the fifth. And remember, when you multiply an integer exponents with the same base, you add the exponents. So we have 3 plus 5. 3 plus 5 is 8, so 21x to the 8th power. In problem 138, you needed to complete the table. So in this one, you were given the scientific notation, and you needed to put it into standard form or standard notation. And the thing with standard scientific notation is I'm multiplying it by 10 to the third. Well, that's a 1 with 3 zeros. It's multiplying by 1,000. So I know that it's going to increase the value of this term. So, and it's going to increase it by 3 place values. And so if I go to the left, now it's at 19, 129, 1,923. 1, 2, 3. So it's 1,923 and 1/10. Here I'm given the standard notation, 356 hundred thousandths. And so I know this is a very small number. And I need to put it into scientific notation. It has to be greater than or equal to 1, but less than 10. So I'm going to move this decimal, I'm going to increase the value 1, 2, 3. And that will give me 3 and 5600ths. 3 and 5600ths is greater than 1, greater than or equal to 1, but less than 10. And since I increased this value, it's a -3. I'm going to decrease it when I to do the power of 10. So 10 to the -3rd power. For 139, I need to solve this equation. And there's several ways that I can go about solving this. One is I could cross multiply and set them equal to each other. The other way is by doing a fraction buster and distribute the least common multiple between 2 and 5 to both terms. The least common multiple for 2 and 5 is 10. So I'm going to multiply both sides of the equation by 10. So I'm going to put this in parentheses because I have to multiply each term by 10. But before I do that, and the reason why I chose 10 is because 2 and 5 can both divide equally into 10. 10 divided by 2 is 5. And 2 divided by 2 is 1. 10 divided by 5 is 2. 5 divided by 5 is 1. So now this is called the fraction buster because we eliminated the fraction. The other way of doing it, instead of doing it by multiplying by 10, I could just multiply both sides by the denominators. 2 multiplied by 5. And I'm essentially doing the same thing I'm doing over here. 2 divided by 2 is 1. 2 divided by 2 is 1. And those will cancel each other out. And I'm still left with 5 like I was here. And then I multiply this side by 2 times 5. And I'm getting it from these two denominators. And then the 5's will cancel out because 5 divided by 5 is 1. Now I'm going to take this and distribute it to each of these terms, the 5 to each of these terms on the left side and the 2 to each of the terms on the right side. So here I'm left with x plus 3. Here's the x plus 3, and then I'm going to distribute this 5 to both terms. 5 times x equals 5x. 5 times 3 is 15. 2 times x is 2x. 2 multiplied by -1 is -2. And I would have done the same thing over on this side if I did, if I chose to do this method. And now I'm solving for x. Subtract 2x from both sides, 0 pair. And I'm left with -2. 5x minus 2x is 3x. Subtract 15 from both sides, 0 pair. -15 and -2 equals -17. Inverse property of multiplication is division. Divide both sides by 3. That gives me a big 1. And what you do to one side, you do to the other. And so I have x equals -17/3. In problem 139b, I have a system of equations. In this one, since they're both in y equals mx plus b form, slope-intercept form, if this is what y equals, I can plug it into here. I substitute y with 1/2 x plus 3, because that's what y equals. Now I set them equal to each other. So 1/2 x plus 3 goes here, which is now here. And now I solve for x. But I'm going to use the fraction buster method. I want to get rid of these, the 2 and the 3 in the denominator. So I'm going to multiply it by the least common multiple, which is 6. If you can't determine what the least common multiple is, one way to find a common multiple is just to multiply these two numbers. 2 times 3 is 6. So now I'm going to distribute this 6 to each of the terms on the left and each of the terms on the right. And so 1/2 multiplied by 6 is 3, because 6 divided by 2 is 3. 3 multiplied by 1 is 3. so it's 3x. 6 multiplied by 3 is 13. 1/3 of 6 is 2, because 6 divided by 3 is 2. 2 multiplied by 1 is 2, so 2x. 6 multiplied by -4 is -24. And now we're going to solve. Subtract 2x from both sides. Inverse property of addition is subtraction. Created a zero pair. 3x minus 2x is x. Inverse property of addition is subtraction. So we subtract 16 from both sides. That created a zero pair. And we have a negative and a negative. I call this a dig-dig. You dig down 24 feet and you dig down 18 feet. You've dug down a total of -42 feet. So x equals -42. Now, that's what x equals. So we want to find out what y also equals. So we've done half of the problem. So now what we're going to do is plug it back in to the original system. And it doesn't matter which one we do. So here's the original system that we started with. And I'm going to choose the first equation, the top equation, because finding half of something is much easier than finding a third of a number. So instead of x, I'm going to substitute -42, which is here. And half of -42 is -21. And -21 plus 3 equals -18. For problem 141, what kind of association does the scatter plot have? Well, you can see that as the height increases, the age increases. And the height is dependent on the age. The younger you are, the shorter you are. So we can see that since as the height increases, the age increases, they're both positive. That means we have a positive association. And for part B, you need to draw a trend line, or the line of best fit. And you try to get at least half of them above and half of them below. My line of best fit, I feel, is a little too high. If I were to redraw it, I'd probably bring it down a little bit more, because I have 1, 2, 3, 4 above, 1, 2, 3, 4, 5, 6 below. So I would try to bring it down just a little bit more. For problem 142, at the farmer's market, Laura bought 3 pounds of heirloom tomatoes. If the tomatoes are priced at $8 per 5 pounds, what did Laura pay for her tomatoes? So this is a proportional relationship. We have the cost and we have the number of pounds. So here's the total cost and the number of pounds. And for the numerator, everything in my numerator is going to deal with money. The values in the denominator are going to deal with pounds. So we know that Laura pays $8 for 5 pounds, and we want to know what did Laura pay, so we don't know what she paid for 3 pounds. And we can solve this by cross-multiplying. So we have 5 multiplied by x is 5x. 8 multiplied by 3 is 24. Inverse property multiplication is division. We divide both sides by 5. This created a big 1. 1 multiplied by x equals x. 24 divided by 5 is 4 8/10. So Laura will pay $4.80 for 3 pounds of tomatoes.